Good morning, all students. As we know, we are suffering from the lockdown situation due to coronavirus. So, it is, I think, it's essential for the students. The classes are closed right now. So, we are going to start the online classes and videos related to the subject and syllabus of industrial microbiology, biotechnology, life sciences, environmental, food technology, and these topics are helpful in every streams of life science. These topics are helped many times, and you consider you carry on your syllabus with our classes. And today I am going to start the topic fermentation. This is the most important part of microbial decomposition, and actually fermentation is my topic in industrial microbiology part third students. So you see, first I will tell you about the fermentation. What is it? We can easily define the fermentation. This is the breakdown of larger molecule into a smaller one under suitable condition through the help of microorganisms. As for example, fermentation done spontaneously in nature for the decomposition of peels and waste vegetables from the household kitchen to the environment, and a spontaneous generation of microorganism there for the decomposition of the substrates. But we cannot say fermentation, because fermentation, the word says only for the targeted product. When once you target the product, then the metabolic activity done with the help of microorganisms can say fermentation. In other words, fermentation may be defined as: fermentation is the process in which the breakdown, the decomposition of organic substrates through the microorganisms, and also known as microbial cultures, for the useful products under controlled conditions. If you see, controlled condition is applicable where the targeted product is achieved. Controlled conditions means aseptic conditions, that conditions totally free from microorganisms, free from contaminations, free from uh, any hazards like physical, chemical, or microbiological hazards. So if you can see the reaction regarding fermentation, that is substrate, you can take any organic compound or natural resources, then their biochemical reaction takes places, and the product is found in three steps. First is metabolite, another is extracellular micromolecules, and third is biomass. We can say, to understand the fermentation, substrate change their nature, texture, color, taste, and entire properties they're from the raw material. Now, we should not be discussed about some points when we'll discuss before fermentation. First is growth media. You should must know how many types of growth media, and one concept I telling you, every microorganism have their own media for their growth and growth and decomposition. So you should decide, first you plan the product, your targeted product, and then you decide, then you choose the microorganisms, microbial culture suitable for that, and then you decide the suitable growth media for the process of fermentation. The next important sources, the nutrients. How many nutrients are required for the microbial growth or perfectly doing the metabolic activity? The first is carbon source, which come from uh, the raw material itself, like molasses, starch, and any other carbon source. Second important source is nitrogen source, that is urea, salt, yeast extract. Third is growth factor. It totally depends upon the media and media composition. Another requirement is trace element. We can say this is the micronutrients, which is required in very small amounts, or sometimes it present in the raw material. So that is zinc, manganese, molybdenum, ferrous, copper, etc. Another thing is inducers. Inducers are the specific for a specific product, which induced the productivity of your targeted product. And another is anti-foam agent. See, anti-foam agent required to control the foam formation during the process of fermentation. You can see when agitator uh, agent process, uh, then the liquid material moving in clockwise direction, and during this movement, huge quantity of foam may be formed during the process of fermentation. So you can use a small amount of anti-foam agent, like fatty acids and other suitable anti-foam agents required in the fermentation process. You must know about the all steps, all types of sterilization process. You must understood the control of environmental conditions, how you control the environmental conditions, like air analysis of your production area, uh, the personal hygiene of manpower involved in the fermentation process, the cleaning process of machinery, it's called CIP, clean in place, the cleaning process of equipments, utensils used during the fermentation. You must know about the aeration process and mixing process. You should must aware about the vessels of microbial cultures, shakers, fermenters. Fermenter meaning thereby how many types of fermenters you must know. I'm telling you next class how many types of fermenter, but you must know the brief idea about the fermenter. Uh, uh, the types of fermenter I am going to mention here. You must know the fermenter configuration. Configuration means how many parts of fermenter, how many gestures are installed in the fermenter, because fermentation is a totally controlled process. We can't use, can't understand, can't do this process manually. So you must know the probes, the devices, the equipments used during the fermentation, use installation of fermentation, how many devices are used in there for performing their different processes. So this topic is fermentation, fermenter configuration, and the type of fermentation. We can see batch fermenter is a different fermenter, continuous STR tank fermenter is another different fermenter, tubular fermenter, fluidized bed fermenter, solid state fermenter. And for all types of fermentation, we should must know the computer control of fermentation process, because nowadays every fermenter devices, every fermentation fermenter are installed with a computer control system through a biosensor. You should you should must know the processing about the computer control, how it control, how the panel is worked, how can just how identify the efficiency or deficiency inside the fermenter during the fermentation. So let us we start uh, overview, a short definition of different uh, points we should must know before to start the fermentation. We should must aware with these topics before start the fermentation. The first is sterilization. You should have the idea about the sterilization. You studied in previous years about the sterilization, like physical sterilization, chemical sterilization, and the production of microbial culture. Now, the next topic is fermenter configuration. A fermenter are a closed vessel mostly used for the production of various products on large scale. We can use fermenter on a small scale also as pilot plant fermentation, which is used in the laboratory for research and development activities. So fermenter is also used on R&D level for research and development, known as the pilot plant fermenter. But on industrial level, I will discuss about the large scale fermenter. So you can see as the configuration of the fermenter, there are different capacities, ranges from 10 to 100 liter, which is used for a small scale, and very large as 1000 liter to 10 lakhs liter capacity as used for large scale fermentation, or it is known as commercial fermenters. Basically, fermenters are made up of good quality of stainless steel, and their volume depends upon the requirement of producers, meaning thereby how many volume, how much volume you decided to ferment during your targeted product. The fermenter depend upon that. Now, the commercial fermenter fitted with many facilitations such as pH probe. First is pH probe. pH probe of a fermenter maintain the pH requirement through addition of acid or alkali, and gives the reading by regular monitoring of the pH on your screen. pH of the culture goes down slowly with the growing microorganisms, and they're essential to maintain at their optimum level. The second point is dissolved oxygen probe. The DO probe maintain the requirement of oxygen during the process. Many oxidation reduction reaction takes place in the presence of oxygen if the process are anaerobic. We can say, see, fermentation is mostly anaerobic, but if your targeted product and the microorganism is aerobic, then you should need the passage of oxygen, and the oxygen pass through a filtration fitted in a fermenter that is known as HEPA filter. Uh, so it is clear that the fermentation done in absence of oxygen, that is called anaerobic, and those fermentation is proceed in presence of oxygen, that is called aerobic. Now next point is cooling jacket. The cooling jacket of the fermenter having two valve opposite to one another. One is the cooling water in, and another is the cooling water out. It is essential to maintain the temperature of fermenter. You should decide the production, you should decide the temperature during the production protocol given to you to operate the fermentation. So you can increase or decrease your temperature. You can balance your temperature with the cooling water and hot water. The next point is temperature control unit. The temperature control unit is also fitted in a fermenter. This unit sense the temperature inside the fermenter and display in a digital way through the regular monitoring and records of the fermenter. Next is impeller. It is a fermenter fitted with impeller and attached through a shaft. Impeller regulated by a motor as fitted top of the fermenter, moving in clockwise direction to give the agitation, means proper mixing, and aeration, means supply of oxygen. And another important uh, device is biosensor unit. Every automatized fermenter have installed the biosensor unit. It is an analytical device which convert a biological response into electrical signal. I repeat again, biosensor is an analytical device which converts a biological response into an electrical signals, meaning thereby the efficiency, the deficiency, or any unbalancing during the fermentation. It shows on the control panel of computer through the biosensor device, and then you should complete the requirement of fermenter without touching any manual operation. So a fermenter also fitted as sample line. Sample line is used to draw uh, the sample to check the growth uh, and development of culture in fermentation. Another device is fitted is air filter. Air filter is fitted for the passage of filterized air, which is free from contaminants, free from any microbial contaminants, physical contaminants and dust particles. The another device is a harvest line. A harvest line is fitted on the bottom side of fermenter to harvest the product after the completion of your fermentation. A new culture addition, the next device is culture or nutritional additional device. Nutrition addition device is fitted on the top of the fermenter. It supply the requirement of nutrients required during fermentation. And a most important step is cleaning and maintenance. When you start the fermentation process, cleaning and maintenance, as you know, the CIP is the most important step of fermentation. It should be done before to prior to start the fermentation and after finish the fermentation. It is completed in 5 steps. The regular monitoring and examination of physical and biological changes is accomplished under a septic condition of the fermenter, because these parameters enhance the microbial growth of medium. Therefore, the maximum yield can be achieved through the regular monitoring of fermenter during processes. So now I'm going to discuss about the fermentation process uh, in form of flow chart. If you can see in a flow way, first topic, first point to end point, how many steps are involved in the fermentation for inoculum development. First, you should get the stock culture. A stock culture we the two way to got the stock culture or microbial culture. One is the isolation technique, the self isolation, the self research and development process is done in a certified laboratory, and we can identify the culture and then use in the fermentation for targeted product. Another way is that we can buy the microbial culture from laboratories as it will MTCC, microbial type of culture collection. As we know in India, IMTech, Institute of Microbial Technology Chandigarh, is known as the MTCC. MTCC means the institute responsible to collect and preserve the different microbial cultures used for the commercial uses, as well as for industrial production or for research purposes. So we can purchase or prepare the microbial culture, pure culture itself. Then first we make the stock culture. A stock culture made on the slant. Um, you will see a stock culture once prepared, then it increase the volume through sec flask. Sec flask culture means a small fermentation process for the preparation of seed or mother culture. Mother culture required, the requirement of mother culture actually depends upon the uh, raw material, depends upon the raw material, how much the volume of raw material is we going to ferment. So sec flask, after that sec flask culture is transferred in the seed fermenter, and seed fermenter is actually called the starter culture. So once the starter culture is prepared, then you ready to do the fermentation process. Now you should must aware about the different phases of microbial growth, like lag phase, log phase, stationary phase, and decline phase. uh, we had discussed previously in previous classes. Now we start the different fermentation process. First is batch fermentation. It is also known as fed batch fermentation. uh, I will tell you how the fed batch fermentation or batch fermentation works. So you can note the process of batch fermentation. All substrates are added at the beginning of the procedure. Means you should add all ingredients required in the fermentation before to start your process, and enhancement of the closed batch processes. This is widely used for the production of penicillin. During the batch process, substrate is added in increment of the fermentation progresses. The fermentation to many secondary metabolites is catabolized by high concentration of glucose or carbohydrates. For this reason, the critical element of the nutrient solution are added in a small concentration at the beginning of the fermentation, and those substrates continue to be added in a small doses during the fed batch production phase. And this also complete the lag phase. Lag phase means there is no NOE microbial growth have been seen. There is only proper mixing of raw material with inoculum, microbial culture actually. Lag phase starts from beginning stage of fermentation. When lag phase completed, the process transferred in log phase. Log phase is a complete microbial growth phase. During this phase, microbial growth is started, and it will take time. The properties of the raw materials are going to change during this phase, and at the end of log phase we got the maximum growth of microorganisms of the targeted products. Now this is the complete batch fermentation process. Many equations are in there, uh, how the process is, how the concentration is increases or decreases, how the uh, reduction and oxidation process are takes place is there. So this is the end of the batch fermentation, and I request you, if you like the videos, kindly, this is the first class, so kindly subscribe my video like this, and advice on my WhatsApp. how you like these videos, how this like my video, and suggest me any point, any matter you don't understand. I will mention to clear in my another video. So thank you.